Hello everybody, this is Professor Jason Kim. Today's lesson is about real numbers and the operation of sign numbers. In real number system or number system, there is a rational number and irrational numbers. Rational numbers are the number that you can express in terms of a fractional format. That's rational number. So rational number consists with fraction and integer, and we talked about the fractions in previous video. Now we're going to talk about the integers. Now integer, we have positive integer and 0 and negative integer. So 0 do not have any sign, but positive and negative contain the signs. Now in real numbers consists with, again, irrational number like pi, radical 2, radical 3, those we call irrational number because real value of these numbers are never ending and never repeating decimals. So it do not have any ending numbers. That's why it's an irrational number. For example, pi is like 3.141526 and goes forever. And it never ends. That's why it's irrational number. Now, like radical 2 is also irrational number. The reason why is actual value of radical 2 is 1.414. And goes forever. Now, rational numbers are the number that if there is ending, and you can express in terms of a fractional format. So like A over B. Okay. So again, rational number are the number that can be written in ratio of two integers A over B, while B is not 0. So all those numbers are the rational numbers that we talked prior. Now, irrational number is again like radical 2, radical 3, pi, those are what we call irrational number. In a fraction, we have a proper fraction. It's a fraction, the numerator is smaller than denominator. Now, contrast to proper fraction, there is an improper fraction. So im means not proper. So improper fraction is the one that numerator is bigger than denominator. So that kind of fraction we call improper fraction. Now, mixed fraction or mixed number is like integer and fraction is mixed together. A complex fraction is fraction inside of the fractions. When there is a fraction inside a fraction, then it's a complex fraction, like 2/3 over 4/5. Decimal fraction is like one with a decimal point, like 2.31. That's a decimal fraction, or in short, we call decimals. Now, the integers consist of negative integer, 0, and positive integers. And 0 do not carry any sign. Okay. Now, whole number, so I'm keep telling you the terminologies. Whole numbers are non-negative numbers, like 0, 1, 2, 3, 4, 5. That's we call whole numbers. Natural numbers, which also we call counting number, is positive integers, not included in zeros. So it's like 1, 2, 3, 4, 5. So difference between whole number and natural number is the whole number includes 0 and natural number do not have 0 and they are all positive numbers. Okay. Now there is a line with all the number in it. We call number line. So number line represent all the real numbers. So negative integers, these are negative integers. 0, and then you have a positive integers. So we call this line as a number line. Now positive integers are integers that are located on the right side or positive direction from the 0 position. So right side from 0 is positive integers. And negative integers are the integers that are located on the left side from the 0 position. So, and the 0 is neither positive nor other negative. Okay. There is something called opposite of the number or opposite direction. Opposite direction is that, so opposite direction of, let's say, 5 is negative 5. So opposite direction of positive is negative. By the way, when there is no sign, it's always positive. So when you have like 5, that means it's like positive 5. So opposite of 5 is negative 5. Okay. Then what is opposite of negative 5? Then it's positive 5. Opposite of 0 is 0. Okay. Now when you talk about the sign and like this, right? You never call this plus and minus if you meant to say sign. If you meant to say sign, this is positive and the other one is negative. So this sign is positive and the other sign is negative, we call. Okay. Absolute value of the numbers. Absolute value of number is the number x is the distance between 0 and x on the number line. It's written as bar and the 5. So absolute value of, let's say, positive 3 means that absolute value represented by this 2 bar before and ending. So that represents the distance between in the number line, let's say here is a 0 and here is a positive 3. So the distance between here to there is absolute value of 3. So absolute value of positive 3 is 3. Then what is the absolute value of negative 3 then? So absolute value of negative 3 is also from the number line 1, 2, 3. The distance from negative 3 to 0. That's absolute value of negative 3. So distance is also 3. So absolute value end up with that value without the sign. Okay. So absolute value of 3 is 3. Absolute value of negative 3 is 3. But if the sign is outside, negative absolute value of 3 become just negative 3 because negative was out of the absolute value or before the absolute value. And when you have negative absolute value of negative 3, then you keep the negative and inside of absolute value, negative 3 turn into positive 3. So you have negative with the positive 3, which is negative 3. Now, like number 5, absolute negative of absolute value of 7 minus 3 become, you do 7 minus 3 first, which is 4, and then answer become negative 4. Now, like number 6, absolute value of 3 minus 7. So actually, 3 minus 7 turn into negative because you are taking bigger number away from smaller number, then you always end with a negative. But that become negative 4. So, but you still have absolute value. So then next step become absolute value of negative 4 become 4. Okay. Now, number 7, absolute value of 7 plus, negative 7 plus absolute value of negative 4. So you have to do individual absolute value operation. So absolute value of negative 7 is 7 plus absolute value of negative 4 is 4. So now you have a 7 plus 4. So 7 plus 4 become 11. So final answer become 11. Okay. Anybody have any question? Now, number 8. Number 8 said 5 minus absolute value of negative 2. So in that case, absolute value of 5 is 5. So you write 5 there. And then minus absolute value of negative 2 become 2 there. So 5 minus 2 become 3. So final answer of this operation become a 3. Okay. Now here are some exercises. Does everybody pause the video and do the exercises and check your answer with the answer key at the bottom of the workbook. Okay. Now next topic is type of numbers. Now identify the following numbers. Now positive 3 is positive number. Negative 5 is negative number. 0 is neither positive or negative. So again, here we talk about the signs. So sign, you don't say plus or minus. On the sign, you say positive or you say negative. Now, 0.5 or 1/2 is not an integer, but still rational numbers. Okay. Number 5, 75 or negative 3/4, negative 0.75 or negative 3/4 is rational numbers. And radical 2, radical 3, radical 5, radical 7, radical 8, radical 10, and pi are all irrational numbers. Okay. So we talked about positive number, negative number, zeros, and rational number, irrational number. Now, number 7 is about the square root of a perfect square root of the numbers. Okay. So, like, perfect square root means inside of the square root. So this sign we call square root sign because the index 2 here is not usually written. So either this or without the index, we call this as a square root sign. So square root of 1 is always 1. Square root of 4 is always 2. And square root of 9 is always 3. Square root of 16 is 4. Square root of 25 is 5. So when you have a perfect squared number, it can be turned into integers. So square root of 1, square root of 4, square root of 9, square root of 16, square root of 25, all these numbers are rational numbers because they turn into integers. Now, number 8, absolute value of negative 4 is 4. We learned this. Negative absolute value of negative 4 become negative 4. We learned that as well. Okay. So exercise 2, identify the types of each number fall under. Okay, so now think about this number and think about what this number belongs to. And check with your answer key under the bottom of this section. And pause the video and think about each numbers.